And welcome to this lesson. This video is going to be on 3.5, equations of lines in the coordinate plane. It is another lesson in our chapter 3 study of parallel and perpendicular lines. So let's go ahead and get started. The first thing we need to know is what slope is, and this is a review. Since this is geometry class, we know that you learned in Algebra 1 what slope is. It measures the steepness of a line. We do need to make sure that you remember the symbol or the abbreviation for slope is m. And you see that variable. Oftentimes that represents slope. Now there are several formulas or different variations of the formula for slope. When you're looking on a graph, we call that rise over run. Okay, make sure you put this in your notes. So one formula for slope is rise over run. And basically that's the same thing as change in y over the change in x. Okay. So these are fractions. Slope is really good to be written in fraction form. One number on top, one number on the bottom. Rise is on top, or change in y, that's the same thing. And then the run would be on the bottom, which is your change in x. Okay, so these are two formulas written when you're dealing with the coordinate plane. Now, sometimes you're asked to find the slope between 2 points, and you're actually given two sets of points, two ordered pairs. And the formula you want to use for that is y2 minus y1 over x2 minus x1. And these are all three of these formulas mean the exact same thing, okay? Just written differently for different scenarios that you may encounter. So those are the formulas for slope. Once again, the variable or symbol for slope is going to be m. Now there are different types of slope. Slope can look differently. Lines can steep differently. So you can see a positive slope when we read with the convention of reading left to right. If we start on the left side of the line, as we go across the graph to the right, it is going up. When it goes up, it is positive slope. Okay. Alternatively, if we're going down as we go from left to right, then that would be negative slope. If you are not going up or down and just flatly walking across, that's zero slope. Okay. And when you have a vertical line like this, where the steepness is so great that you can't walk on it, this would be like walking up a wall. This is undefined, okay? That's impossible to walk on, all right? So it's going to be undefined slope. So make sure you know the difference between these two, zero and undefined. They are different. You do have to say that flat is zero specifically, and that vertical is undefined. And you cannot interchange those, okay? All right, let's get into writing equations in slope-intercept form, all right? The formula for slope-intercept form is going to be y equals mx plus b. Okay, and I know you saw this in Algebra 1, so this is a review for sure. Okay. Y is going to come from a y coordinate. You've seen that before. X is an x coordinate. But m is the slope. We just mentioned that above. And b stands for the y-intercept. I know you've seen y-intercept before in Algebra 1 as well. Make sure you have this formula down, y equals mx plus b. That is the formula for slope-intercept form. It's got this name because it includes the slope and the intercept, right, in that order. So that's why it has that name, right? We make sure you label your m as slope and your b as y-intercept. And that's basically the notes for this section. We're going to get into some practice problems that review these concepts. So 1, 2, and 3, we are going to be graphing these equations. Now, if you notice, all of these equations are written in slope-intercept form. They all say y equals something x and then something behind it, okay? Let's look at number 2 together. Y equals negative 7x plus 5. So since this is in slope-intercept form, then I know that the number in front of x is going to be m, and the number behind x is going to be b. I can clearly see it's written in that format. And when we get ready to graph it, it's always a good idea to graph the y-intercept first, because that's a single point, okay? And it's relatively easy to graph. You just go on the y-axis, which is the vertical one. Let's highlight that so it sticks out. Okay, so this is our y-axis every time. The vertical line down the middle is your y-axis. And you want to plot 5 on that line. So you really just read it and then put your dot there. Okay, so that's step 1. Once you have the y-intercept plotted, then you go back and use the slope to plot more points, okay? We learned in the first chapter of geometry, you have to have at least 2 points to create a line, and that's what we're graphing, our lines. So you have to plot at least 2 points. I would recommend 3 or more, enough to go across your given coordinate plane, okay? So the slope this time is negative 7, 1 over 1, because remember, slope needs to be a fraction. If it's not a fraction, just stick a 1 under it, and that's how you can turn it into a fraction. So this top number is our rise or fall. I say rise if we're going up, fall if we're going down, and then the second number on the bottom is your run, okay? So remember, top number tells you up and down, bottom number tells you left and right. Okay, so starting from the point that we plotted, we will go down 7 because it's a negative 7. So from here, I'm just counting 1, 2, 3, 4, 5, 6, 7, and that takes me down here to negative 2. But I'm not going to put a point right there. I'm just hovering right now at this location. And now I use my second number, which is the 1. It tells me to run 1 space. That means go across either left or right. Since it's positive, that means go to the right and put a point. Okay. So that's 2 points. And then I can connect those 2 points to create my line. Now, normally I say do 3 or more, but you see we're going to run out of space because you repeat the same process. You would go down 1, 2, 3, 4, 5, 6, 7, which seems like it might be down here, and then over 1 again. And see, now that's an estimate, so that's not precise, but it kind of looks consistent. And then you would connect the 3 points. So something like that, but make sure your line goes through all of your points. And that's how you use slope-intercept form to plot lines in the coordinate plane. Okay. We have more practice problems there. You're doing the same thing. You're going through and graphing these equations and their lines in the coordinate plane. So let's look at number 4. It's in slope-intercept form. Y equals mx plus b. So I know m is negative 2/3. And I know b is negative 1. I'm pulling that right from the equation. The number in front of x was m. The number behind x is b. Now that I have that identified, I am going to plot the y-intercept, and I just plot that directly on the y-axis. So I need to come down to negative 1 and just put a dot right there. That's from the y-intercept. Then I use the slope. My top number is negative 2, my bottom number is 3. That means I'm going down to 1, down from the y-intercept that I just plotted. From that location, I go down to 1, 2. To the right, because that's a positive 3 places. 1, 2, 3. Okay, so I want to make sure we point out here that y-intercept, you go to the number given and plot it on that number. You're not counting, you're just plotting the number on the label. When you use the slope, however, those numbers are counting spaces, not going to a label. You're actually counting spaces. Okay, so from here, top number of the slope is negative 2. That means go down 2 spaces from where you are. So 1, 2. Bottom number of 3, positive 3, means go to the right 3 spaces from where we are right now. 1, 2, 3. Okay. There you have it. Now, what about this space over here? Looks like the line would continue on, and it does. If you wanted to plot points in this direction, you would just need to do the opposite of this slope. And when I say opposite, I mean changing the negative 2 to positive 2 and changing the positive 3 to negative 3. Okay. So that because that is mathematically equivalent, changing the sign of both numbers. So positive 2, negative 3 is the same slope. It just allows you to create points on the other side. So if I start here at the y-intercept, a positive 2 would tell me to go up 2 spaces, 1, 2. And the negative 3 on the bottom would tell me to go to the left 3 spaces, 1, 2, 3. Plot that point, and now you can see that clearly is the same line. Okay, we can do it again. Up 2, 1, 2, to the left 3, 1, 2, 3. And there's our line. All right, number 6. Y equals negative 2x plus 4. What's the y-intercept? What's the slope? The y-intercept is 4. I'm highlighting the y-axis. The y-intercept is 4, so I'll come to the 4 and put a dot on the y-axis. The slope is negative 2, but we know we need a fraction. So negative 2 over 1. So I will be using this slope by going down 2 to the right 1 from this original point. So go down 1, 2, right 1. And I keep doing that as many times as I want. Down 2, right 1. Down 2, right 1. And I think that's enough to plot the point, the line. Okay, let's look at number 8. This says x equals 1. This is different. It's not written in the format of y equals mx plus b. So it's not telling us the y-intercept or slope that we can just read off like we were doing before. But we can think about this. It's basically telling you no matter what, x is equal to 1. X is equal to 1 no matter what. Okay? So I can pick my point here. X is 1. And this is the x-axis, remember, because the vertical one is y, so the horizontal one is x. So I'm going to put my 1 right here. And it's telling me no matter what y is, x is 1. That means you could pick 3 and x would still be 1. You could pick 6 for y and x would still be 1. You could pick -4 for y and x would still be -1, okay? So hopefully you get the point. Whenever you have x equals a number, you're going to get a vertical line through that number. See how I'm going through the number 1 down here on the x-axis? That's not a coincidence. That came from x equals 1. So anytime you have x equals a number, you get a vertical line through that number. Okay. Likewise, when you have y equals a number, you're going to get a horizontal line through that number. Next section. Here we want to write the slope-intercept form of the equation using the information that's given, right? So not graphing, we're writing the equations in the format y equals mx plus b because it says slope-intercept form. And we know that's y equals mx plus b. So we know when we do that, we'll have y is y, right, equals. We need to fill in slope, or m, x is x, and then we need to also fill in b, or the y-intercept. That is the format every time for slope-intercept form. So m is slope. We just read slope is 7/3. So we just fill that in right there. 7/3x. And then y-intercept is -3. So you're right, -3. And you're done. That is the equation in slope-intercept form. Y equals 7/3 x minus 3. That's it. Number 12, look at the information given. We have a point this time and a slope of 2. We still want to plug it into the equation y equals mx plus b. Okay, so let's take that formula, write it down. Notice they gave us a slope. They didn't explicitly tell us y-intercept. So we're going to have to solve for it. As long as we have a number for every other position, we can solve for a y-intercept. So we know the slope is m. We know that's 2. That goes right there. But how does this point help us? Remember, anytime you have an ordered pair, the first number is always x and the second number is always y. You can use that. You can always employ that strategy when you're trying to figure things out. So y is 3, and x is 4. And since I have every other variable substituted, I can solve for b now. So 2 times 4 is 8. Still have a 3 over there. We want to solve this for b. 3 minus 8 is negative 5. Okay. So b is negative 5. Now I have all that I need. I have the slope, I have the y-intercept. I can rewrite this equation like I need to. So my final answer is going to be y equals 2x minus 5. That would be the equation that goes through the given information in slope-intercept form, okay? And that is all for the lesson today, guys. If you have questions about this video, please put your comments down below or send me those questions or ask them in small group. I have a lot of videos on this topic from Algebra, so you can use those to study as well. Thank you.